Hey kids, it's Mrs. Butcher. I hope you've had a great 2 weeks off of school, and now you're watching your next video. Aren't you excited? So to start out, I want you to practice these two problems. I want to do some review. I want you to solve both of these quadratics. And I know you know how to do this because we've done quadratics for quite a while now. So push pause and work these out and then check back with me. Okay, so on this first one, you should have factored it and then set each factor equal to 0 and got x equals 4 and x equals -1. On the second one, you didn't need to factor it. You can just move the 2 to the other side and then take plus or minus the square root, and you get plus or minus the square root of 2. So on this one, we have a couple of rational answers. Remember our types that we learned at the beginning of the year? These are rational, because they can be expressed as ratios or fractions. These two, and there are two there, these two zeros are irrational. They cannot be expressed as ratios or fractions. So today we are going to focus only on the rational zeros. We will move to all of the zeros tomorrow. Here is another review problem for you. This one I'm going to talk you through. Find the zeros of y equals x cubed minus x squared minus x plus 1. So we know in order to find the zeros, we want to try and factor. And the first thing you always want to do when you've got 4 terms is see if it will group. And in this case, it will group. So out of the first group, we can take an x squared, and we have x minus 1 left. Out of the second group, we're going to take -1, and then we have x minus 1 left as well. So one of our factors is x minus 1. The other factor is x squared minus 1. And then we say, oh look, we have a difference of squares. And so you draw on your knowledge of that, and we have the x minus 1 copies down, and then x squared minus 1 factors to x plus 1 and x minus 1. So now to find the zeros, we're going to set each of these factors equal to 0, and I get x equals 1 and -1 and 1 again. So if I just asked you to list the zeros, you could just tell me 1 and -1. However, it is important that that 1's in there twice. And if you remember from before, we learned that that is a 0 with a multiplicity of 2. And so it counts twice. Alright, so now that we're done reviewing, let's begin. We've got the rational zero theorem that we need to write down. The rational zero theorem says that if f of x equals a sub n x to the n plus etc., basically if any polynomial has integer coefficients, and that integer part is important, integer coefficients, then every rational zero of f has the following form. Every rational zero that we can find, so that doesn't count the irrational ones like the square root of 2 that we talked about before, but all the rational ones will fit the form of a factor of the constant divided by a factor of the leading coefficient. Factor of the constant, that's the last one, divided by a factor of the leading coefficient. That's the very first one. So let's look at example 1 that we did a while ago when we solved x squared minus 3x minus 4 equals 0. We found our zeros to be 4 and -1. If we list out our possible rational zeros, sorry, taking a while to write this, possible rational zeros, then we're saying factors of 4 divided by factors of our leading coefficient, which is 1. And the only factors of 1 are plus and minus 1. So our factors of 4, we have positive and negative, and we always have positive and negative. So I'm just going to put plus or minus and then a parenthesis. 1 goes into 4 times, right? 2 goes into 4 2 times. and 4 goes into 4 one time. Those are the factors of 4, 1, 2, and 4, positive and negative. Because I could do negative 1 times negative 4, and that would give me 4, and so on. And on the bottom, we just have plus or minus 1. So, as you guys know, anything divided by 1 is itself. So our possible rational zeros are positive and negative 1, positive and negative 2, positive and negative 4. Forget that parenthesis. We have 6 possible rational zeros. The 2 that we came up with that are the actual zeros belong in that list. 4, positive 4, and negative 1 are both in the list that we came up with. And that's true for any polynomial. Any rational zeros that you have will fit in the list of the factors of the constant divided by the factors of the leading coefficient. So here's an example of how I might ask you this. I might just say, hey, find the possible rational zeros of this polynomial. I don't need the actual ones for this question. I just want the list of all of the possible ones. So that possible is a big keyword there. And when you see that possible rational zeros, we know we're going to take factors of the constant, divide that by factors of the leading coefficient, which in this case is 1. And any time that we're dividing by factors of 1, we can just skip the dividing part. So we've got factors of 6, which are positive and negative. 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6. So we have the positive and the negative of 1, 2, 3, and 6. That is 8 possibilities, in case you can't count. 8 possibilities. So, when we want to factor these big ones and we have no idea where to begin, we're going to make a list of possibilities like this. And then we can start doing synthetic division, which we learned in the last module, to test and see which ones are actual zeros. So we'll just keep going with this same one that we're doing. Now we're going to find the actual zeros. I now have a list of 8 possibilities. That's a lot to test, but it's better than just picking random numbers out of the air and testing them. And I always just start at the beginning of the list. I start with 1, and I do synthetic division into my polynomial, which is 1 minus 1, negative 5, positive 3, and 6. Bring down the 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. Negative 5 plus 0 is negative 5. 1 times negative 5 is negative 5. 3 plus negative 5 is negative 2. 1 times negative 2 is negative 2, and 6 minus 2 is 4, which is not 0, so 1 doesn't work. Try another one. We'll go with negative 1. Into 1 minus 5, 3, and 6. Bring down the 1. Negative 1 times 1 is negative 1, plus negative 1 is negative 2, times negative 1 is 2, minus 5 is negative 3, times negative 1 is 3, plus 3 is 6, times negative 1 is negative 6, plus 6 is 0. Yay. So we know one of the zeros now. We've actually factored this down a step. Scoot that up so we can see. So we know that one of our zeros is negative 1. The factor that goes with the 0 of negative 1 would be x plus 1. And then the rest of this is going to be x to the, now it's the third because it's 1 power lower, minus 2x squared, minus 3x, plus 6. Okay, so we have factored this down a step. All right, let's keep it going. We got to take it down further because this might be able to factor further. We only know one of the zeros. So now our possible rational zeros, same thing, still factors of 6 divided by factors of 1. But we've already eliminated 1. If 1 didn't work in the beginning, it's not going to work for the rest of it. So we can try something else. Let's try 2. So I'm going to take a 2. I'm not going back to the original. I'm going to my new one here, or this one right here. So 1x cubed minus 2x squared minus 3x plus 6, because I'm trying to factor that down now. Bring down the 1. 2 times 1 is 2. Negative 2 and 2 is 0. 2 times 0 is 0. Negative 3 plus 0 is negative 3. Times 2 is negative 6. 6 minus 6 is 0. So yay, 2 works also. So now we know that we still have this x plus 1 that we had before, and now we have an x minus 2, and then these three numbers give us x squared plus 0x minus 3. And I know that x squared minus 3 is not going to factor any further because that's not a difference of perfect squares, so therefore we're done factoring it. We still want to solve it, so we still have to set each of these equal to 0. So now if I set that equal to 0, and that equal to 0, and that equal to 0, I get x equals negative 1, 2, and this one, that's going to be x squared equals 3, x equals, never forget your plus or minus the square root of 3. So positive square root of 3 and negative square root of 3. You can write it as plus or minus, but I just did this so that you could see that there is 1, 2, 3, 4 of them. 2 are rational, and they came out of our list. And then because we used the list to narrow it down, we were able to factor using our other skills and get the 2 that are irrational. And I want to tell you a little secret about this one. I did it this way on purpose, using synthetic division and then using synthetic division again. But on this particular problem, when you got to the cubic function, which was, let me find it again, which was the x cubed minus 2x squared minus 3x plus 6, you could have factored that by hand. That groups. So we could have just grouped that. We still would have got the same thing. We still would have got x squared minus 3 and x minus 2. So either way that you do it, you'll get the right answers. They won't always work by grouping. So that's why I wanted to go ahead and teach you the other method. That way you know it, just in case grouping doesn't work. Alright, we have another example. I know this is going to be a long video because I do have 2 more examples to do. But you know what? You haven't had a video in a long time, so get over it. We're going to start this one out the exact same way we did with the last one. I asked you to find the zeros of this cubic function. And grouping isn't going to work on this one. We got a 10 and a 15 and then a 16 and a 12. Those aren't going to be the same. So we know we're going to have to list our possible rational zeros. And those possible rational zeros are going to be the factors of 12 divided by the factors of 10. Okay, so the factors of 12, we've got plus or minus. I'm just going to put a big plus or minus in front of my whole thing. We got 1, 2, 3 goes into 12, 4 goes into 12, 6 goes into 12, 7, 8, 9, 10, 11, and 12 goes into 12. 1, 2, 3, 4, 6, 12. We're dividing each of those numbers by 1, by 2, by 5, and by 10. So if we're going to write out our possible zeros, we have to take 1 and divide it by each of these numbers, then 2 divided by each of these, then 3 and 4 and 6 and 12. So let's write them all down. We got 1 over 1, which is 1. We've got 1/2. We've got 1/5. We've got 1/10. We've got 2 over 1. 2 halves, which equals 1, and we already wrote that down. 2/5. 2/10, which is 1/5, and we already wrote that down. We've got 3 over 1. 3 halves. 3/5. 3/10. We've got 4 over 1. 4 over 2 is 2. We wrote that down already. 4/5. 4/10 is 2/5. We've got that already. 6 over 1. 6 over 2 is 3. We have that already. 6/5. And 6/10 is 3/5, which we have. 12 over 1. 12 divided by 2 is 6. We have that. 12 over 5. And 12 over 10, which is 6/5, which we've got. So look at all these possibilities. This is where this method gets to be not useful anymore. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers, and it's plus or minus of each one of those. So that's 32 options here. Ugh. So that means we'd have to go through and possibly try up to 32 different numbers. That's a lot. And if this was the Stone Age and you had no other tools, then that's what you'd have to do. But we do have graphing calculators. And so what we do when our possibilities, our list of possibilities is just too many, or when you're just too lazy to even look them up, is to make a graph. And so we're going to sketch this. We're actually going to graph it by hand to show you how easy it is. But you could just graph it in your calculator and narrow it down just by looking to see where does the graph cross the x-axis. So let's graph this sucker by hand, because you're going to have to do that on the test too. We know the end behavior. On the right, it's going up because it starts with a positive 10. And on the left, it's odd power, so odd means opposite. Left is going down. All right? So now we just need to figure out, oh, we know the y-intercept. That's 12. So I need to make a table and figure out where some more of these points go. All right, so if I choose 1 for x, I'm just going to plug it into my original polynomial. I know you can't see it, but you should have written on your paper, right? If I plug in a 1, then I'm going to have 10 times 1 cubed is 10, minus 15 times 1 squared, 10 is minus 15, minus 16 times 1, and plus 12. 10 minus 15 minus 16 plus 12 is going to give me negative 9. So at 1, we're down here at negative 9. Okay, that means that, ooh, look, one of our zeros is between 0 and 1. Okay, we know that much. And then let's try a 2. Plug in a 2, we get 10 times 2 cubed is 80. Minus 15 times 2 squared. 15 times 4 would be 60. Minus 16 times 2, so minus 32, plus 12 gives us 0. So, look, now we automatically know one of them. We can stop playing with this and graphing it if we want to. 1 was negative 9, 2 was 0. But we know it's going up on the right. We know it's got to come down on the left, so we know there's another 0 over here somewhere, because it's got to go down, right? We don't know exactly where, but we have a starting place. We're going to start with the 2. And we're going to divide the 2 into 10 and negative 15 and negative 16 and 12. So we're going to bring down the 10, and 2 times 10 is 20. I didn't mean to change colors, but anyway, 20 minus 15 is 5, and 2 times 5 is 10, and 10 minus 16 is negative 6, times 2 is negative 12. We knew this was going to work out, but we needed to do it so that we could know that it factors to x minus 2, and 10x squared plus 5x minus 6. And anytime you hit a quadratic, you should be able to solve a quadratic using multiple other tools that we've learned, such as quadratic formula or completing the square. So now we're going to do the quadratic formula. We're almost done, because I know if I set that equal to 0, one of my zeros is 2. And we saw that on the graph. When we set this equal to 0, we're going to get 2 more. And if you look on the graph, I'm going to pull it down for a second, there's 1 here, and there's 1 over here. We need to get these 2, these last 2. Oh, that did not work, did it? Well, whatever. Let's try that again. All right, so we know x equals 2. And then we're going to use the quadratic formula for the rest. And so you've got to remember that. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which is going to give us negative 5 plus or minus the square root of 265 all over 20. And 265 does break down because 25 goes into that, so it is negative 5 plus or minus 5 root 23 all over 20. And 5 and 5 and 20 will simplify, so we get negative 1 plus or minus the square root of 23 all over 4. So we have our zeros now. We have 2, and we have negative 1 plus or minus the square root of 23 over 4. If you were to punch that in your calculator, you'd see that it's those two other zeros on the graph. We don't really need to know the exact values of it. These are irrational, and this is rational. And this is the way I would want your irrationals written anyway, in root form. All right, so that was a nice problem, wasn't it? Now we're going to do one more, because we have to do a word problem. We just do. We always have to. And here it is. Some ice sculptures are made by filling a mold with water and then freezing it. You're making an ice sculpture for a school dance. It's to be shaped like a pyramid with a height that is 1 foot greater than the length of each side of its square base. The volume of the ice sculpture is 4 cubic feet. What are the dimensions of the mold? All right, so let's sketch a picture. I know pyramids are not easy, but it is a square pyramid. So there's our square pyramid. And it says the height, so remember your height is measured in the middle there, is 1 foot greater than the length of each side of its square base. So we'll make this x and this x, and your height will be x. 1 foot greater than would be plus 1. All right? So what are the dimensions of the mold? All right, you have to know how to find the volume of a pyramid, so let's do that. Volume of a pyramid is 1/3 big B, which is the area of the base, times the height. So that's going to be 1/3 times, in this case, x squared times the height, right? So we know the volume is 4. We're going to plug in all of our values that we've got. And we don't know x, and we know the height is x plus 1. So I now have my polynomial set up. Okay, now you know anytime you have a polynomial, we need to set it equal to your good friend 0. So we're going to multiply this out. I'm going to distribute, and I'm going to get 1/3 x cubed plus 1/3 x squared. And then I'm going to say minus 4 equals 0. And when you don't want to play with fractions, if it's an equation, it's fair, it's allowed, as long as it's an equation, to multiply everything by 3. You can't simplify just an expression that way, and some of you guys have been trying to do that, but you can't. However, in this case, you can do the equation by multiplying it all by 3 and having x cubed plus x squared minus 12 equals 0, because the roots are going to be the same. And then we have this cubic function that we need to factor. Don't be fooled. It has 1, 2, 3 terms, but that's not a quadratic. You can't go, oh, what multiplies to get negative 12 and that's to get 1. It doesn't work that way. We have to have our possible rational zeros, which are going to be plus or minus 1 and 2 and 3, 4, 6, and 12. Factors of 12 divided by factors of 1, which doesn't matter. So these are our possibilities. And we need to start trying. I'm going to try 1. When I try 1, into 1 x cubed plus 1 x squared. Be careful, 0x minus 12. We bring down the 1. 1 times 1 is 1, plus 1 is 2. 1 times 2 is 2, plus 0 is 2. 1 times 2 is 2, minus 12 is negative 10. Nope, didn't work. Try something else. Let's try negative 1. If we try negative 1 into our 1, 1, 0, negative 12, you'll see that this synthetic division starts getting really fast after you do it enough times. Bring down the 1. Negative 1 times 1 is negative 1, plus 1 is 0. Times negative 1 is 0, plus 0 is 0. Negative 1, that's not going to work either. Let's try 2. And you just keep trying until you find something that works. Or if you have access to a calculator, obviously you could graph it and look for the zeros. But I don't have one with me. So bring down the 1, 2. 2 and 1 is 3. Times 2 is 6, plus 0 is 6. 2 times 6 is 12. 12 minus 12 is 0. Yeehaw, we finally found a 0 that works. And we've got it factored down a step. Okay, so we are factored to x minus 2, because that's what goes with that. and then x squared plus 3x plus 6, because that's what goes with that. All right, equals 0. We're still trying to find zeros. This one we know is going to give us 2. And if I try to solve this sucker, it doesn't factor. So if we use the quadratic formula, we'd have negative 3 plus or minus square root 3 squared minus 4 times 1 times 6 all over 2 times 1. Automatically, I can see that 9 minus 24 is a negative number. And we will solve for imaginary zeros later, but in this real-world problem, we're not going to have an imaginary eye sculpture. So the only 0 that works is 2. And the question asked us what were the dimensions of the mold. So the mold has a base that is 2 feet by 2 feet, and it has a height of x plus 1, so 2 plus 1 is 3 feet. And we are super geniuses now, because we've got it. And here you go, because I know you've missed them. It's an awesome math joke.